Okay, team, we're now going to work through some more worded questions using this multiplication of algebraic terms. This is more of a real world application where you can actually see how this is used and why it's important to learn. So I want to work through question 15 with you, and then we're going to talk through question 16 as well. Okay, so a rectangle has an area given by 24x squared. Okay, so if we draw this, so we've got our rectangle. What it's saying is that one way we could write it is we could say that this side is 8x long and this side is 3x long. Okay, so x would be the same unit. Okay, so we could say that this perhaps is x. So this side is 8 of those long and this side is 3 of those long. Okay, so when we multiply 3x by 8x, because remember that's how we calculate the area of a rectangle. We multiply this side length by this side length. So when we multiply 3x by 8x, okay, so if we do our breaking apart, we have 3 times x times 8 times x. So I end up with my 3 times 8 times x times x. Okay, so I know that 3 times 8 will give me 24 times x, which I know is x squared. Okay, so then I simplify it down even more by taking out that multiplication sign, and I end up with 24x squared. Okay, so that's one way that we could do this. There are more, so let's find 3 different rectangles that give us 24x squared. So what we need to think about is this is one combination of numbers, okay, of coefficients that will give us 24. What other combinations will give us 24 in terms of multiplication? All right, so we need to think about the factors of 24. What numbers will multiply to give us 24? I know that 1 and 24 will multiply to give me 24. I know that 2 and 12 will multiply to give me 24. So these are factors of 24. I already know that 3 and 8 works, okay, to give me 24. What other numbers are factors of 24? So I want you to think about what else could be in there. All right, what about 4? Does 4 work? What would multiply by 4 to give you 24? So 6. So 4 and 6 will give me 24. So I've got another 3 combinations here that will give me 24. So I could have 8x times 3x, or I could have, I'm going to move over here because I've got a bit more room, 1x times 24x, okay? And I could just write that as x times 24x. I could have 2x times 12x. And I could have 4x times 6x. Okay, and they would all look very different as rectangles, but they still give me the same area of 24x squared. Okay. Let's have a look at question 16 now. Okay. So the top of this box is a rectangle. Yep. So top of this box, so this part up here where you pour the cereal out, rectangle. Okay. It says it has a length 3 times its width. Okay. all measurements are in centimeters. If the width is x, so it's already told me that this width is going to be called x. Okay, so it's already said that that side length is x. Write in algebraic terms what would represent the length in centimeters. So this side, I'm just going to change color so that we can see this. All right. What will this be? Okay, this side length. Now remember, it already said back here, the length is 3 times its width. Okay, so use that information and think about how you would represent the side, this length here, okay, in algebraic terms. Right. The area of the rectangle is length times width. Write the area of the top of the box as a multiplication problem using algebra and then simplify. Okay, so it told me that this was 3 times its width. So I know that this is 3x. It's 3 times as long as this side. Okay, so to do the next question, the area of the rectangle is length times width. So I need to multiply my x by 3x, okay, because it's this side length multiplied by this side length to get the area of the top of the box. Now, remember when we're simplifying expressions with multiplication, we break it apart and then combine it together. So we've got x simplified is just x, multiplied by, to break this apart, we end up with 3 times x. Now remember, I'm going to take this coefficient, I'm going to put it on the left-hand side because I have no other number to multiply it by, okay, except for that imaginary 1. And 1 times 3 is just 3. So I'm going to move my 3 over to the left-hand side, and I'm left with x times x on the right-hand side. Now remember, we always know x times x is x squared. So I end up with 3x squared. Okay, when I take out all of those multiplication signs and I simplify x times x to x squared. Okay, so that is question B. Okay, so you should have 3x here to show that side length, and you should now have the area of the top of the box is 3x squared. Now, telling me that top of the box x is actually equal to 8. Okay? Can you please now try to solve question C on your own, knowing that x is equal to 8? All right? I want you to think about how you can check your answer, all right, to part C. And I actually want you to work through down to, I just want you to complete E for now. All right, have a go. We'll leave the video here. Can you try to complete those for me? I have uploaded a picture as well if you need help, or to see the pictures a little bit clearer, but have a go. I will pause here and then I'll show you the answers in a second. Alrighty, so here we go. So we've got 3x, we've got 3x squared, which we did. We've got 192 centimeters squared. Remember, important to have centimeters squared because we got told that it was in centimeters. When x equals 8, the width equals x, which is 8 centimeters, and the length equals 3x, which is 24 centimeters. Okay, so 24 times 8 equals 192. Okay, so that gives the same answer as if you just substituted 8 into your algebraic expression. Okay, the quickest way was to substitute it in rather than doing it really long-handed. So hopefully you did do some substitution. Have a practice if you didn't. And if you could upload your photos for me to your Google Slides or email them to me, that would be awesome. I'm going to make one more video talking through this next part. Good work, team.